Okay, I think I have checked most of the quizzes and also checked whether is my question has some mistake in it. And after I check and I see that I think for average it is if I average all the score from all of you, um, it's around 48%. So in scale of from 0 to 100, in average you get around 48. A few of you get good, I think good job, uh, getting 12, around 12 answers correct. And also, oh yeah, 11 to 12 answer correct. And I think that's really good. And yeah, because the quiz is done in the online platform, so the weaknesses of the online, if you're doing the quiz or any assignment on online, if I want to make sure that you are really doing all the things by yourself, focus on that quiz alone. I need to make sure and I need to restrict all the environments. That's why one of the things that I restricted is each question has a timer, and different questions, different timer set. Uh, some of them maybe seconds, 50, 40, and some is minutes, 2 or 3 or 5. And uh, I do hope that it is enough. I know that it seems not really okay for some of you, uh, but I think that is actually how we can also learn to manage our minds and manage our thinking on a stressing time. Yeah, I think this is uh, maybe a good practice for you. Okay, and yeah, I think most of you already done the quiz. I think one or two students still not able to join. I'm not sure whether it's because the internet connection or what. But I think now here I check all the students from Andres, Ardian, Hans, Helen, Jonathan, Maria, Scott. I think all of you already done the quiz and I've checked all the score. Maybe tonight or maybe this week I will announce the score. So you will see the score probably on the Google Classroom. Okay, so yeah, okay. Let's start the lesson first. Okay, let me go through. Okay, first let me review yesterday questions. Um, this is I think a little bit tricky for the first question. Which of the following statement couldn't possibly be true? Okay, the answer is A. Okay, let's see what B and C um, has to offer. For B, P has degree 3, which means it's at least x cubed. It is x cubed. If you're going to see x cubed itself, it can have this, in which there is no maximum or minimum point. Okay. This means local maxima, local minima. There is no local minima or local maxima. You will notice this in more details in calculus, why this has happened and how we can elaborate the graph and how to sketch the graph. Okay. So this is, it can be true, B. And C, P has degree 4. Degree 4, it's even functions, right? And you know that it can be this or it can be this, right? But it has one local maximum, so probably like this. So it's also possible, right? So it's also correct. But number A, two local maxima, two local minima, that's if you are arranging your equations x cubed plus blah 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 blah, you wouldn't be able to get two local minima and maxima together in the same graph. So that's impossible. So that's why the answer is A. So that's how uh, you get your logical reasonings. Okay. Okay, and this one here, I believe we need just to check the long division, and we get the remainder of the two. Okay. All right. And it seems because we done our quiz one, and maybe if we done quiz two after some chapters, so now we are focused on quadratic, polynomials, rational zeros, and maybe later we will have some exponential and logarithm. Maybe after that we'll be having another quiz. So maybe uh, usually we will have midterm week on second week of November. So maybe before that, so you can focus on your other courses midterm. Okay? So maybe uh, in the early November, and then uh, you have the midterm week. Okay. Okay. Now we move on to we call the Descartes rule. But before we go to the Descartes rule, let me review with some. Uh, okay, let me start with finding rational zeros. A little bit review of what we done in the last sections yesterday. So we have px. Um, so the question is write polynomial p in factor factor form, and then find all possible zeros. Meaning zeros, if you heard the zeros terms now, then that means you need to find the solution for x. Okay? What is the possible solutions? Okay, now to solve this, we can start by writing possible rational zeros. Possible rational zeros means this is our p over q. Okay? This is p, this is q. Okay? Or let me write in another term. This is factor of the constant term, and this is factor of leading coefficient. Okay? But I don't want you to be confused or overwhelmed with words and terminology. Just remember that this is P, okay? This is Q at the front, so at the back and front, okay? In a polynomial. So possible rational zeros is factor of 6, right, 0 of 6 and factor of 2. Okay, now we start with 6. 6 it can be plus minus 1, plus minus 6, right? And plus minus 2, plus minus 3 factors, right? I think this is elementary school, right? So 2 factors will be plus minus 1 and plus minus 2. Okay, so we will have 6 by 2, factor 6 by factor 2. We get, uh, let's start with 1 and start with 2 and start with 3, start with 6, and then start with sorry, one first. Yeah, I think uh, you can check one by one. 1 divided by 1, 1 divided by 2, 2 divided by 1, 2 divided by 2, 6 divided by 1, 6 divided by 2, 3 divided by 1, 3 divided by 2, and some of them are equal. So this is the thing, the factors. Okay. And we will have the number that we need to check is plus minus 1, plus minus 2, plus minus 3, plus minus 6, plus minus half, plus minus 3 over 2. Right? Okay. Now, the idea, okay, if you are really blank and we need to find some clue, so this is like we are investigate something like a detective. Right? So we need to find which one our suspect, right? So we have several numbers, and we check several numbers. We are going to put into our function p. Let me move this to. So we check. Okay, testing the numbers. Maybe first we check one, checking x equal 1. Okay, now if you look at, probably this p is not too complicated, but if you're dealing with some complicated one, you can just use our synthetic divisions. Okay, synthetic divisions, writing down, let me write px 2x cubed plus x squared minus 2x plus 6. Okay, now writing all in terms of synthetic division and divide by 1. This is 2, 2, 3, 3, 10, negative 10. I think we have a remainder here. We have a remainder, so it's not equal 0. So 1 is not zeros. And then checking maybe x equal 2, 2, 1. This is 2, 4, 5, 10. Oh, we got the zeros. So 2 are zeros. And because of that, we can write this x minus 2 and then write this term with red color, 2x squared plus 5x minus 3. Okay. And we need to find the factor. I think for the quadratic, it's not too difficult, right? Maybe I'll check this out first. Let me check this with. Okay, okay. We check with this table. 2x, x, let's say 3, 1. We need to have positive, so we need to have more in this. This is 1, 3. To make it plus 5, we need to make it negative 1. So we have 2x squared minus x. Okay, that's correct, right? So the factor will be, or the zeros are 2 and then half and then negative 3. And of course, if you look back at our testing point, minus 3 is our here, 2 is here, and half here. So that is in all our suspicions, right? Before. That's how you can do, and actually it's quite helpful if you are dealing with some equations, okay, especially this polynomial. Okay? But remember, you can do this for the zeros that are so we can do all this p over q, find a possible rational zero whenever we are dealing with polynomials. Polynomials. Okay. Now the other way to help finding the solution or finding the zeros is by using the we call the Descartes rule of signs. Okay? I'm not sure whether you are familiar with the Descartes rule of signs, but this is actually uh, just a method to help. Okay? Not really that. So if you are using this rule of signs, you will not get the direct answers like what is the zeros. Okay? This is just to help narrowing uh, your suspicions. Maybe you have a set of numbers, and then you can narrow all together using the Descartes rule of signs. So let's see what it says. So let p uh, let p be a polynomial with a real coefficient. The number of, and here's the important thing, number of positive real zeros. Positive real zeros meaning its x is, for example, positive 1, positive 2, that's positive real zeros. Okay. Positive real zeros of the polynomial either is equal to the number of variations in sign or is less than that by an even whole number. Okay. Maybe you need to sometimes to process all these words. But let's say the other one. It's similar. The difference, this is just the negative real zeros equal to the number variation in sign in p, and see this p with negative x inside, or is less than that by an even whole number. Okay, let me point out and how we can deal with this. Okay, first we are going to look for number of variations in sign. What does that mean? Okay, look at here. Look at this p. We have our signs, right? This is positive, right? Positive, right? And then after that, negative 13, and then plus 6. Okay? So positive, positive, and then it changes to negative from x squared to negative 13x. Right? The sign is changing, right? So we are mark this as, oh, there's one changes. So that it's what it means for the number of variations, the number of variations in sign. Okay, and then we need to check the negative x. So we need to put negative x inside the equations and check the uh, the number of variations. So based on what this rules, okay, it says that the number of variations in signs will determine how many positive zero or how many negative zero in an equation. Okay, so we see that we see here it's one sign changing, right? So there will be at least maybe one positive zero, and why we have this two now, because this Descartes rule is actually our just a method to check, just a method to check. And maybe let's give you another example to see how we can deal with this. Let me choose the other part and let's uh, do some tests and how we can deal with it. Yes. Okay, if we have the functions here, let's say f of x is x cubed. If you look here, we have 1 and we have 2. So at least we have 2 positive zeros or 0 positive zeros. So that is, if you look at the rule of sign, is equal to the number of variations in sign in Px or is less than that by even whole number. Okay. Even whole number meaning you need to minus with at least 2. Oh, sorry, I just remember. This should be 2. Sorry. So yeah, it's yeah. That's why I'm quite confused. Okay, that's true. So it has 2 positive zeros. Okay. 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 Let's see this one. So it's 2 positive zeros or 0 positive zeros. So we have uh, so the card. Let me write here. The card rules is uh, investigate polynomials and uh, creating a path. Okay. So if you look at when the function is uh, with the negative x inside, this will be negative x cubed, and then this will be negative, still negative. Okay, it's negative, negative, positive, and then positive. So we will have from negative to positive, it's 1, and then there's no other changes, right? So we will say it has 1 negative zeros. And because it has 1, okay, and of course you can minus with 2 because it's already 1. So the the fact from this Descartes rule, there should be one negative zeros. Okay? So if you want to find the real zero, we want to find the real zeros using P over Q, finding the list. You have 2 and 1, so you have list uh, plus minus 1 plus minus 2, right? Or at least plus minus 2. Oh yeah, maybe plus minus 1. All the answers. So we can check. Let's check with 1. Check with 1. Okay, we get 0. We get 0, and we can check also -1. Oh, I should start with -1. Sorry, but yeah, it's same 0, but it should be goes here first because you know that it should be 1 -0. So you should start from here. It should start from here. Start from this is 1. This is 0. This is zeros, so we can start with x plus 1. Let's say that. And I think because it has a positive 0, 1 here, I think we will have another zeros by looking at our possibility here, positive -1 and positive -2. The last one is 2. You can check. And that's correct. So because it's not really that complicated polynomials, we get directly our answer. X is -1, 1, and 2. This is actually true with our predictions. So this is a prediction. So this is a prediction. Okay. Let me give you more detail. So more more complex. Okay, let's see. Okay, if the question is asking how many possible routes for all possible zeros. And this is, I think, quite challenging because it's asking root. Okay? So uh, we need to check first possible zeros from P over Q, rational zeros, and check this. We will have 10 and 1, so it's basically uh, plus minus 10 and the factor of it. So we will have plus minus 10, plus minus 2, plus minus 5, plus minus 1, right? And of course, we can check uh, one by one, but let's see our Descartes rule. Let's see our Descartes rule. For positive, there will be positive, negative, it's 1, positive, negative, it's 2, and positive, negative, it's 3. So 3 variations. So 3 positive 0 or 1 positive 0. Okay. And then we can check the negative x. So we negative x cubed, x squared, negative x, and negative 1. And there will be 0, negative zeros. Okay, so there will be no negative 0. So we will be focused on whether it has 3 positive or 1 positive, right? Now, we can make sure, if we want to make it in more clear detail, we can make a table. So this will be positive, negative, negative, and this will be total. And there will be something here. So first is we have 3 or 1, right? And the negative 1 will be 0 and 0. Okay. The rest, this will be a complex. This will be an imaginary number. So it can be happening for some uh, numbers that are imaginary. So it can be, so the total should be 3, should be 3. So this should be 0, should be 2. So we need to choose. We want to go for 1 or 2. We need to check. Okay? So at least we get our idea from the rational zeros, from the Descartes rule, and then we can at least check all the things here. Okay, checking maybe first, checking with, um, if we are checking with 1, 1 minus 6 minus 5 plus 13, it will be negative, right? So it will be not equal 0. Maybe we check with 2. We check with 2, making the synthetic division. Checking with 2, 1. It's plus. So this will be 5 and okay, 0. So we will have our f of x will be x minus 2 and x squared minus 4x plus 5. Okay. Now if you look here, this probably obvious that if you are going to factor, it cannot be factored, right? And if you see the square root of b squared minus 4ac from the coordinate formula, you will notice that it will be creating a negative, which is, this is going to have like imaginary number. This will be 2i. Okay, and if you try to solve this, the x1 and x2 will be 2 plus minus I. If you are using the whole quadratic formula. So it's 1 positive 0 and 2 imaginary number. Okay. And that's why the root will be this. And you can maybe writing that the functions has 1 positive zeros and 2 imaginary zeros. Okay, that's how you are doing the the Descartes rule. Okay, any questions first? I know this is probably new for you. Oh, by the way, we call this factor is called irreducible factors or irreducible quadratics. Okay, Adrian. So, okay, any questions now? Any questions? So today, I just want to explore this Descartes rule. Okay, if not, then I will move to next one. It's still about the polynomials, and maybe next week we can refresh and have some practice on the Descartes rule and most of the polynomials section. All right. There is some theorem. It's called upper and lower bounds theorem. Okay, we say A is lower bound and B is upper bound for zeros of polynomial if every real zeros C of the polynomial satisfies. Okay, okay. So we will get some help for finding the or proving the upper bounds and lower bounds. So if we divide the polynomial, which means we are getting this division using the synthetic one. If the row that contains all the quotients, which means if we have the division, so this row, the row below here, the result, this is the quotient, right? And this is the remainder. So it has no negative entry. Then B is upper bound. That's correct. B is upper bound. So we want to prove. Okay? And then if we divide by x minus a, which means we divide. So this is, it can be a, it can be b. Okay? If we divide by a, and if the row contains all the quotient and remainder in the bottom, and it's alternately non-positive and non-negative, then a is a lower bound. Okay, let's check one example here. Check -3 and 2, prove upper and lower bound. So first, let me just make it 0. Checking -3. It's 1, -3, -3, 9, 6, 18, -16, 48, sorry, Positive 50 should be, oh fuck, negative, sorry. You'll see here is alternate, right? So this should be lower bounds. And the other way around, talking with 2, it's non-negative. So this should be upper bounds. Okay, that's how you can know which one is the upper or lower bounds. Which means this is can be also helpful if you want to analyze the zeros of polynomial, which means that the zeros of polynomial from here, zeros of polynomial will be at uh, probably at in between A and B. All right. Okay, any questions? Any questions now? Probably I will make some practice for you, especially for zeros, factors, reminder, long divisions, negative divisions, and also the card rule. Maybe giving you maybe 8 to 10 questions. Maybe I will prepare that for by this week and give it to you as assignment too. Okay, so I hope it can help. And um, yeah, I think um, that is actually our course for today. Yeah, that's the so for the lastly, I will give you the feedback time. All right, let me set up first. Okay. Okay, hopefully still remember what I did today and see from the feedback. Let's see how you can do this for the questions. If not, then I think I will take some review. This day, and you can prepare also paper or pen to help. Okay. Okay. All right. We have 6. I think we have 7. Um, for the training. Okay, anyway, let's start the countdown. Okay, see if you get the question or not. This is just a review from yesterday lecture. Okay. Okay. Everyone has voted. Yeah. Okay. Good. Okay. Let's see the other question. 3, 2, 1. Only write the number. Okay? How many? Meaning the number. You don't need to write anything else. Just the number. Okay. 7, 6, 5, 4, 3, 2, 1. Yeah. No one answering the correct one. So you need to put negative x inside first. So okay, I will review that next week. So yeah, still saying congratulations. All right. Okay. Anything to write? Any questions, quizzes, maybe homework, or maybe which part you still feel um, maybe feels not too confidence? I think some of you already emailed me, and I think some. I think one of you are also asking me about the tutor. Uh, I think for calculus part, you can ask the TA first. If he can help you, then maybe you can go to uh, the tutor. I think the learning center they have the they can manage some tutors for you, but I think it's better to check with your TA first. Check with your TA first and see whether you are really need another tutor to help you. Okay, so you can write any feedback like quizzes, like homework. Is it too difficult for the quizzes, or maybe any anything anything? Maybe what aspect on our lecture that need to be improved? No. Trigonometry. Okay, we will get into the trigonometry maybe in November. In November we will get to that part. There will be three chapters trigonometry. So chapter about the triangle, chapter about the circle. Yeah, the time things is something that you need to manage by yourself. Okay? So yeah. Okay, I think I can make up for the time. Like maybe I will make it a little bit longer. Okay. So probably I will make the the time could be If it is just about reasoning, words, or definition, maybe I can make it short, maybe less than 1 minute. But I think for calculation, I will make it uh, at least 2 minutes. I think at least 2 minutes for calculation. I think that should be enough. And for more complicated one, I can make up to 5 to 10 minutes. I think that should be helpful for you. Okay, anything else? If no, then this will be the end of our lecture. I will get back to the quiz results uh, very soon, hopefully tonight or tomorrow, and you can check on Google Classroom. And don't really that maybe if your score are below average, don't don't be worried too much. Yeah, we still have much work to do. So I think that's it for today. And yeah, you can actually leave the Google Meet if you want.